Hello, hello, hello. I hope you guys are having an awesome break, that you're getting a chance to visit with family and all that wonderfulness. I I've been looking forward to this stream a little bit. I actually agonized a little bit over what it was that I was going to cover. What am I going to show you that's going to mean anything to you, that's going to show you some of the cool features of the language. I obviously can't go into absolutely everything, and I can't go as deep as maybe we'd like to on half of these things, but I thought, it'd be good if we could just take where we are in the basics and just add on to it in terms of complexity. And we don't have to get into the deep, dark corners, but I'd like to show you some of the things that are more unique to C#, especially when compared to other companion languages or to peer languages, if you will, things like Java and C++. There's actually a lot of, there's this great Venn diagram, if you will, of how C# has C++ features and how C# has Java features. And then there's this little segment of C# kind of does its own thing like this, right? I love exploring this language, and I'm glad that you're here taking this adventure with me. Come to think of it, I forgot to open up my Twitch stream so that I can see if anyone sends me messages in stream, and that's okay. I am fixing that right now. Okay. So, where we left off last time was we'd covered a bunch of the basics. Today we're going to get into some of the more intermediate meat, right? We talked about declaring variables before, and we even touched very briefly on read-only, which is a constant type field. In C#, there are two types of constants, or let's not say types because that might be a little overloaded, two kinds of constants, okay? We have const and read-only, and they're declared relatively the same. You're going to have something like a private, let's do a const int, and we'll call that cnum, so it's a constant num, right? And then you can have a private read-only int, and we'll call that rnum. Now, don't worry too much about the red squiggles just yet. I know that doesn't work. If you hover over the constant, if you hover over const, it actually, look here in the helper text, in that helper text right over, there we go, there, right? In that helper text, it says a const field requires a value to be provided. Also notice that in the parenthetical next to the int, it says constant, right? If I hover over rnum, it just says field and then int program.rnum. If I were to just declare a regular everyday int and I were to hover over that, notice that I get very much the exact same helper description as I do on the read-only. It says that it's a field. And remember that a field is just a variable or a constant in this case to store data. It's just data about the class or data about the instance of the class. Either way, it's just a place to hold data. But the cnum is very upset, and it's like, no, you have to give me a value. And here's why. There's an easy way to remember which one you need, okay? Const is a compile time constant. In other words, at the time that the code compiles, this thing has to have a clear and definitive value. These are typically set using literals or equations that evaluate to some literal right away. It can't be dynamic. It's not like, let's play with it really quick. If I were to say private static int next ID, or let's call it next num equals 1, and then down here, I were to say next num plus plus, it's not happy about that. And the reason is the expression being assigned here must be constant. In other words, it has to be a literal, it has to be a value that the compiler knows right now. And keep in mind that at the time that an instance of program is created, or at the time that this field is created, it does not necessarily know the exact value of this field in advance, or the compiler does not know the exact value of this field in time. It has to be a compile time constant. In other words, we have to know the value before we ever execute the code. Before we ever execute the code. So I could do something literal. I could do like 24. Or I could do something like 10 plus 14. Or I could do any mathematical evaluation. I don't think I can do things like next num minus 3, right? Because next num doesn't really exist at compile time. It only exists at runtime. So that's not very helpful. All right, so 24. When would I ever use this, one might ask? When would I ever need to know this hard-coded type of constant? And I'm with you that I don't feel like C# needs to have two different kinds of constants, but I also recognize how they've used this to optimize features of the language. And you'll see why here in just a little bit. But imagine for a moment that I had a field like, that I had some sort of field like, I'm going to do my copy pasta trick. And then right here, I'll just put num, let's see, num of days in week, right? 7. For all cultures on this planet, as far as I am aware, every week is 7 days. There is no exception to that. And that is a value that's not going to change, assuming that we don't fall under the rule of some sentient being from another planet that says, no, a week is 27 days or 28 days or 100 days, whatever. Assuming that does not happen, then we are never going to change that 7 to anything else, right? It's always going to be 7. And we know that before the application ever executes. We know that in advance. So having a compile time constant makes a lot of sense. All right, so then we have this read-only field, right? And the read-only field, I can also set right here if I want. I can say it's 42. But what happens if I try to say something like next num plus plus, which, by the way, means use the value of next num to store here, and once that's done, increment next num to the next value by 1, right? Or I could even say, no, increment first, then assign the value to the field. Notice that the read-only field is okay with that. And the reason is this is a runtime constant. Okay, so in other words, one is the compiler needs to know, and the other one does not need to be concretely known until we're executing the code. That also means that if I so desire, I can have a constructor, right? I can have a constructor program that allows me to set that value. I can either take in an argument and then assign the argument, or I can be arbitrary and I can do this. Now, we're going to kind of mess around with this just a little bit. But notice that I set rnum up here, and I set rnum again down here. That's a little different than what you've seen in constants in other languages, right? In other languages, once something is set and it's a constant, that's it, it's over, it's done. You can't set it again. So that's kind of an interesting thing. If I can set it more than once, is it really a constant? Let's look at that in just a moment. Down here, I'm going to create an instance of program, because you'll notice that both the constant and the read-only, the constant and the read-only are both non-static fields, right? They're both non-static fields. So I can come in here and I can say new program, and now I can do a console.writeLine, and I can say const colon, and then I can just concatenate onto that the cnum. And I'm going to try the exact same thing again, except this time I'm going to say read-only, and we're going to talk to rnum. Okay. Now, notice where the code is happy, and notice where it's not. We have this red squiggle worm of death right here, right? And I'm sorry, I just realized in the Discord I wasn't hanging out. I forgot to say this. If you're on the Discord server and you'd like to ask a question, if you'd like to clarify anything, if you have any comments that you don't want to put in the Twitch stream, you can go ahead and throw that into the questions channel on our Discord. If you're not on our Discord server, that's perfectly fine. Shoot me a message on the Twitch stream. I will read it out loud and answer your question. All right. So notice that cnum is perfectly fine. And notice how I'm referencing cnum. Then notice how I'm referencing rnum and how it's not fine. Let's hover over that and see what it says. It says the name rnum does not exist in the current. Oh, sorry. Ha ha ha. Maybe I should spell it right. Look at that. Useful errors. But it's still mad. And when I hover over it, it says an object reference is required for the non-static field method or property program.rnum. Now that's interesting. Notice it says because it's not static, I need to have an instance. Well, why doesn't it say that about cnum? Why doesn't cnum require me to have an instance? I can fix rnum by just grabbing my variable right here, this p, right? I can just say p dot rnum, and it's like, oh, you want the read-only constant from that instance of program. Not a problem, I can do that. But cnum does not actually require an instance. What does that tell you? What does that look like to you as a coder, as an engineer? What does that mean? Think about it. I did not mark this as static. But how do I access it? Look, I'm even in a static method. So it's not the case that the method can see the field even though it's an instance field. It's because constants like this with a C must be treated statically. They're hard-coded. And doesn't that make sense? Because they have to be hard-coded to some concrete value at compile time, not at runtime. So what that means is that every instance of this class, every instance of program, is going to have the exact same value of cnum as every other instance of program. Do I really need that to be an instance field? Do I really need to have an individual instance per, an individual instance of that field for each individual instance of the program class? Not really. It's the same value for every instance, irrespective of when it's created, because it's set to a concrete, literal value. So it really can't be anything else. It's impossible for it to be anything else. So what they've done to optimize that is they've made it so that the const field is effectively static, which, to be honest with you, I did not know in advance till I started playing around with the code and I started seeing this behavior. But it makes a ton of sense. So this is effectively a static field. In fact, I'm kind of curious. Am I able to make this a static field? Can I say static const? Is that okay? When I hover over this, it says the constant cnum cannot be marked static. Can't. Okay, what about this one? Can I make this one static? Oh, yes, I can. But notice that once I do that, I can no longer set it in the constructor. A static read-only field cannot be assigned to except in a static constructor, which is a more advanced topic, or a variable initializer. In other words, right here in line with the declaration. I can set it in the declaration, it's fine. If I comment this out, if I comment that out, then the world is happy and we're good to go. This one down here says, hey, this cannot be accessed with an instance reference, qualify it with a type instead. So since we're in the same type, since we're in the same class definition, if I take away that reference to the object, it's fine. It says, oh yeah, I can be a static read only. So that's kind of interesting. Now, if you have a static, if constants are effectively always static, such that they can never be marked static because there is no difference, right? You can't have static on there twice effectively. If constants are static, then why would I need read-onlys to also be able to be static? Why would I need to do that? By the way, using your screen name, I know who you are, but using your screen name, Tim Mc22, it's good to see you, son. You know, that's a good question. Okay, so the question is there any way that we could get into static constructors? That sounds interesting. I actually have no problem with that. I'll be honest with you. I haven't used a static constructor except in a classroom setting, and that was like 8 years ago. The concept of a static constructor is, first of all, whenever you access a class for the very first time, when an application is running, and the definition of the class is loaded into memory, just the definition itself. All the static members go in there as well. And there's this concept of the first time that you use the class, all the statics become alive, if you will, and then the static constructor fires. In other words, when the static elements need to exist, that is when we get the static constructor to fire off, right? And that allows us to set static fields to whatever they need to be at that time. that gives us a little bit more flexibility and a little bit more control and a tiny bit more dynamicism. But the truth is, we rarely, if ever, use that. We tend to use those if when an application starts, it needs to like load external data. If we need to like get a file or some data from a database just to get the class started, that sort of thing. That's when we'd use a static constructor. But the short story is that a static constructor is about building the class, if you will, or setting the class in its starting state, as opposed to building an instance of the class in its starting state. So that's the difference there. And I haven't used them in forever, so it would take me a little bit of research just to get back up to speed, but that's something that we could look at another time. All right, so here we are doing, going back to what we had before. Let me just back up this example. There we go. All right, so we have const, which is effectively a static constant because it's a compile time constant. Oh, I see. Okay, I'm sorry. I just read the comment from IOPace is I've needed. I can't tell if that says low pace or IOPace, so I apologize if I got that wrong. But I've needed to use that, meaning the static constructor in a project, but I didn't know what. I didn't know that was an option. I went with an init instead. Going with an initializer method is not a bad idea. The only difference between a static constructor and an initialization method is that the static constructor gets called for you, and the initialization method you have to call for yourself. So that's it. That's the only that's a major difference between the two. I shouldn't say that's the only difference, but that's a major difference between the two. But I will make a note of that, and if you would like to know more about the static constructor in a future stream, we can look into that. All right, so going back to our example, we have const, which is effectively a static constant. We have read-only, which we're treating at this point as a non-static constant, right? It could be static if we wanted it to, but we're not going to make it static. It's going to be an instance-based constant. All right, so this one, notice, is set in two places. I'm going to go ahead and comment out the line in the constructor, and we're going to go ahead and run this code. And when we run this code, we should get exactly what you would expect. Because I prefixed the incrementation, it went from 1 to 2 and then assigned the 2 to the read-only. So we have 24 as our static constant, and we have 2 as our instance read-only. Okay, awesome. So now let me uncomment this line. Let me ask you this before I run this code. Is this going to work? The compiler is not arguing about it, but this is not a compile time constant, so maybe it doesn't care. If I execute this code, having set this constant in two places, will it crash or will it run just fine? What do you think? Think about it for a second. Okay. And survey says it works just fine. In fact, you want to see something really interesting? Here I am in the constructor. If I go to cnum, my static constant, and I say, hey, you equal 10, it's like, no, bro, I really don't, because I cannot be assigned to during the constructor. I should have already been assigned at compile time, not at runtime. So that's not even an option. If I change that from cnum to rnum, look, it's happy. Let's do 5 more assignments. And let's do like 12 and 19 and, of course, 1337, right? Now, the compiler's not mad. Everyone's okay. If I go to execute this, where I set it more than once in the constructor, is it going to work or is it going to crash? Think about it. Got your answer? Survey says in 3, 2, 1. There we are. It works just fine. But wait, Mr. Krebs, it's a constant. If I assign the constant, then why isn't it just constant? How is it that I can change it multiple times? Okay, hang tight. What if I instead have another method, not a constructor, just another method? If I have another method that returns void, I'm just going to call it do something. Actually, no, let's give it a real name. Set let's call rnum to 100. Okay, this is a method that literally sets rnum equal to 100, right? That's it. Notice the problem? A read-only field cannot be assigned to except in a constructor or a variable initializer. Where's the variable initializer? Right here. Remember that initialization takes place at declaration. So I can either set it where the thing is declared, or I can go into the constructor and I can assign it a value there. I can do either of those things. But the moment I'm outside the constructor, game over. Can't do it. Not allowed. So yeah, I can set a read-only as many times as I want so long as it's in the constructor. Or I can set it as at initialization and I can use a dynamic value. That's okay. So now you can see the distinct differences between these two different types of constants and why you might use one over the other. To kind of piggyback off of this, if you haven't been in my class before, oh, that's right, Lop Ace. Okay, I'm interrupting myself for a second. So the comment from Lop Ace, it's meant to be Lop Ace. I have to dip. Okay, he has to go, but he'll try to look at this in the future. My apologies for screwing up your screen name. And the funny thing is, I've had you, I've seen that screen name before, and I made the exact same errors. I called him IOPace, then I called him Lopace, and it's like, no, it's Lop Ace. Ah, gotcha. Sorry about that. All right. Now you can see the two different kinds of constants. Why you might use one over the one over the other. Where's my English? Let me slow down for a second. If you've been in my class, then you know about us having a die class, right? If you've been in my course, if you've been learning code from me, then you know that we can have like, we might define a die class. This is like rolling a die in a game. And we might have a private constant for the number of sides. So I might have private int num, I just call it sides. We can call it, yeah, let's call it num of sides. Num of sides, or sides, or whatever you want. And this one normally is something that we would set in the die constructor, right? We would have, you know, I know this is irritating me. I'm just going to change it to sides. There we go. So you have sides, and then here we would say this dot sides equals sides. Okay. So this is what we normally do, except that we don't want at any time, even on accident, for the number of sides of a given instance of a die to change. Once we have a 6-sided die, that instance of that die is always 6 sides. We could make a new instance and have a 20-sided die, or a 12-sided, or a 10, or 100. It doesn't really matter. But we don't want that number of sides to change after it has been set for that instance. And so a const here does not make sense. Why doesn't it make sense? Well, because then every die would have the exact same number of sides all the time. And it would have to be set at compile time, not at runtime. And that's not very useful. So we don't want to use const here. But if we use a read-only, that will work for our needs so long as we set it in the constructor, which we do. And that's perfectly fine. Remember that previously we had getters and setters properties. We had properties. And so I might do something like this, where I have a get, and then we do sides. We'll do return sides, right? But if I try to do a set, if I try to say sides equals the value that was set, it's going to bark at me. It's going to say like, no, bro, you can't do that. This is a read-only field. Okay, no problem. I just won't have a set. And you can do that. You can do that. Can you do this with an automatic property? I don't think so. But let's try it really quick. Let's find out. Here's an automatic property, right? It's an int. We're going to call it sides, and we're going to call this let's see, a read-only property. And it's barking, and it says the modifier read-only is not valid for this item. Okay. All right. All right. So yeah, I probably wouldn't use an automatic property here. I'd probably back up and do just a manual property with a get only and a manual field to accompany, right? I'd probably do this. Pro tip. Notice that if you type in prop, there's actually a few different versions of prop, okay? This is an attached property. This has to do with visual elements or dependency objects when you're using GUI architecture and when you're building a GUI type application. Same is true of a dependency property. This can be, it doesn't have to be for a GUI, but this is a property that is meant to depend on the value of some other object. And then you have prop full. And prop full, if you do that one and you do tab, then you get this thing. I can say sides here. I can come down to capital sides. It's capital sides. Hit enter, and now I can go back through, and I can type read only, and I can get rid of the set. And I've accomplished the same thing. Little shortcuts in Visual Studio go a long way. They go a long way. All right, so that's enough about constants for right now. You kind of get the picture, you understand, so I'm okay with that. A const is a compile time constant, whereas a read-only is a runtime constant. All right. Okay, if you would like to keep the code, but you would like it out of your way, just as a reminder, you can use, because this is Visual Studio, you can use something called regions. Regions say, if you start with a hash mark, if you start with a hashtag, if you will, octothorpe, there we go, and then use the word region, you can then give it a name. We'll call this the die class definition. And then if you come down to the end of that selection of code that you want to encapsulate in the region, you do hashtag end region. And now you've created what's called a region in Visual Studio, which is collapsible. And when you collapse it, the name of the region shows so that you know what's in that region. It's purely an IDE thing. It is not a C# language feature. It's an IDE feature. And it allows you to get rid of a lot of visual noise, so you don't have to like delete a bunch of code. So regions are super, super handy. Yeah, I'll keep that around just in case. Same thing here, except let's do it like so. I'm going to do an end region, and then up here, I'm going to do a region, oopsies, region constants demo. Oops, demo. There we go. Control KD to format, and then collapse that down. I'm going to go ahead and you've seen this in action. I'm not too worried about it. I'm going to go ahead and get rid of that. And we're going to clear out main so I can show you some other stuff. Or rather, let me cut that out and let me create another method down here. Public, static void demo constants. Paste the code, and then I'm going to grab all this, and I'm going to move it into that region, actually, so that it's out of our way. Expand that and bump this thing down. There we go. Collapse. Okay, good deal. So, next on the list. So imagine for a moment, let's do public static void greet user. And let's say that we take in a string for the name of the user. Now, it's possible that this name, because it's a reference type, it could be anything, right? So I'm going to come in here, I'm going to say CW, I'm going to be like, actually, before I do that, let's have another string, we'll call it greeting, equals, and then we will say welcome, comma space, and then here, oh, it's a greeting, no regrets, here we go. And now we're going to say greeting plus equals, and I want to add the name onto this thing. Now, I purposely split this into 2 lines so I can show you this next thing in a clearer fashion. So I'm going to say plus equals the name of this user. And that's not a problem if the name is something meaningful and useful. And then just right here, I'm going to go ahead and just display the greeting. And then, yay, okay, good. And right here in main, I'm going to go ahead and call greet user. And we're going to pass in, let's pass in Jake. I like that name, Jake. It's not mine, but I got a dear friend whose it is. All right, so I say greet user Jake, okay? And now when I run this thing, it says welcome Jake, and we're fine, right? Okay, all right, but that doesn't stop me from the worst possible scenario. It doesn't really stop me from passing in blank either, and I get that, but it doesn't stop me from passing in the worst possible thing. I could just pass in null. I could just pass in null. And if I pass in null, this is what it looks like. Notice that it literally takes up no space. There's the space character there that separates the comma from the name, but then there's nothing, and then there's the bang. So this still allows me to pass in null. If I'm in a situation where null is a possibility and I don't like that, if I want to handle null and I want to do it gracefully and all that jazz, then what I can say is I can encapsulate this name in a parenthetical because I've got multiple statements here. I'm going to have multiple pluses here or multiple operators here in just a second. I can come here and I can say double question mark. And what that question mark means is, hey, if this thing that you're trying to use just happens to be null, then alternately we can use dear user instead. Now when I execute this code, notice that because name was null, dear user was used instead. This operator, this double question mark operator, is known as the null coalescer. At least that's how it was taught to me, and suddenly I'm starting to wonder if that's really what it's called. But I'm going to call it the null coalescing operator. This allows me to take null and replace it with something else at runtime. So if I do receive null, I can just use this other thing instead, right? This is often done whenever you're just trying to get some value and then use that value right away. And I often use this for names because names can often be null. They are rarely just white space or just blank, but that can also happen. And there are some different coding mechanisms we could use for that. But I wanted to show you the null coalescer specifically. Okay, cool. So now that you've seen the null coalescer, that's really cool and all. But then what if I wanted to say something like, let's go here, and then let's say int num of chars in name. And normally I would just say name.length, and that would tell me how many characters are in their name, right? But we kind of have a problem. We have a problem. First of all, I'm going to say your name is, and then we will concatenate num of characters in name, num of chars in name, plus, and then just to save on all sorts of logic and stuff, character / characters long. Okay, this is great, but when I go to run this thing, what happens? I get a null reference exception. Because even though the null coalescer saved me when it was time to add a null name to a string, and it did, it's all, hey, dear user, then I tried to take that same null object. I tried to take that same null object and then call one of its properties. But that property is an instance-based property. If the instance is null and I try to use the property, what happens? I get a null reference exception, right? So that's cute that I can replace a null value with some other arbitrary value. But what if I need to use that object and it's still null? Well, there is the null check operator, which is a single question mark after the thing followed by a dot into a method. Now, just to make the compiler happy, I'm going to do something that you may not be familiar with. See that int on my declaration at line 51? If I add a question mark in front of it, that becomes a nullable int. Notice that before I did that, the code was not happy. There was actually a red squiggle worm of death. If I hover over this and it says, hey, I cannot implicitly convert type nullable int to a regular non-nullable int. An explicit conversion exists. Are you missing a cast? The reason is the following. Let me put this question mark here so you can see. Whenever I use this thing, right, this null check operator, it means, hey, if at any point this thing is null or anything before it is null, that might be in the chain of calls. Like, for example, well, I can't show that just yet. But what this null check operator says is, hey, if name is null when you go to call this property, instead of throwing an exception, I'm just going to return null instead. I won't throw an exception. I won't do like a null ref exception. It won't be a problem. I'll just return null because something in the chain of command was null and I couldn't do my job. So instead of throwing an exception, I'm just going to return null. And you're okay with that because you told me I could with that null check operator. So because this could return null, I've got to have a variable that can store null. And right now, if I run it with name null, notice it says your name is 2 space characters long, right? Two spaces, characters long. There should be a number here, but because our name was null and we used the null check operator, it returned null. So that means that right here, I can say, hey, look. Oh, actually, you know what? We could do it right here. We could say, hey, if that thing actually does return null, just use 0 instead. And then I can get rid of that because it is guaranteed to never be null thanks to the null check operator and the null coalescer. So when I run this thing, now it says your name is 0 characters long because the thing was null. It has no name, has no characters, right? We could come up with a string default name, and we could then take this, copy it, pasta, and then down here, we'll just say, hey, look, in that case, use the default name, and instead of the name length, if that thing is null, then just use default name dot length, which we are going to guarantee is never null. Or if it is null, we should throw an exception, so I'm okay with that, right? And now that we've done that, since we're using the dear user default name, it says that our name is 9 characters long. If I go back then and instead of passing in null, I pass in Jake again, then we should see an appropriate response all across the board. So you have the null check operator and you have the null coalescer. Super useful. And you even saw for a moment there that I can take a primitive value type and I can even make that nullable with the nullable question mark. One quick word here. So it ends up, I've been following developments in the language in general for some time. And again, the original creator of C# is still working on the language. He still works at Microsoft. He's working primarily on the C# platform. And he started releasing videos for what they're going to do for version 8 when they release C# version 8. And one of the things they're going to do is they're going to make it so that anytime you want to allow a field to be set to null, you have to put a question mark in front of it. That means strings. That means any of our reference class types, right? That means that previously, if I took my die class and I made a variable of type die, I could just say die d equals null. In version 8, I'm not allowed to do that anymore. If it doesn't have a question mark in front of the type, it cannot accept null. That's intentional. And I got to be honest with you. And maybe this is me being a noob in my own right and all that stuff, but I'm not a big fan of that new feature. And I think part of it is just that I'm used to the language saying, hey, look, if it's a reference type, it can be null. I can see how it's more communicative, how it will make more sense to newer developers who come along, but I'm not a big fan. I don't want to have to put a question mark in front of absolutely everything that could be null, that might be null, that, I don't want to have to do that. But it does also, on the flip side, it does mean that I can expect a special kind of exception or the proper kind of exception on any type where I don't include a question mark because it shouldn't be set to null. I shouldn't be allowed to pass in null. It should prevent that from happening. So it's got its ups and its downs. I suppose it's probably an equal trade-off. It's just me having to change habits to including a question mark when beforehand I didn't have to. But that's a feature in 8. And 8, I want to say there's a release candidate out. I don't think 8 is officially released yet, but I'll have to double check that. All right, so back to our nifty little demo. So that is the null coalescer and the null check operator. Fun. All right, again, features that I love in C# because they are super duper useful. So I'm going to go ahead, cut that out, And, you know, I kind of kept that there because I thought I might use it, but whatever. And I'm going to go ahead and place that there, but I'm going to go ahead and wrap that in a region. And we will call this the null operators demo, right? And we'll come down here. We will end that region. Except you got to spell end region correctly, all one word. And then we can collapse that code. Boosh. All right. Don't need that demo line of code, so we're good there. All right. Now, previously we talked a little bit about how you can interact with strings, right? If I have like some sort of string here, words, and I can set that to hello, everybody. 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 If you don't know Homestar Runner, then that reference will make sense. All right, here we go. So we have words, and you saw what we could do earlier, right? We can index into it. I could take words, and I can get the first character by doing an index at 0. I can do the last character by getting the words dot length with a capital L, and then I can subtract 1, and that'll give me the last character. I can take words, and I can call to upper or to lower, and a bunch of other stuff. Contains, just there's a lot of things you can do with a string, and it's super, super cool. But one of the things that we often have to do is that we have to concatenate. We have to take 2 strings or more, and then we have to bring them together. We have to, you know, make them make some sort of visual sense. It has to be readable. For example, I might have something like, say, a public class person, and that person may have a private string name. Actually, you know what? I'm sorry. I'm going to make automatic properties here. I'm not going to be too worried about constants or this is private, that's public, or whatever. Let's just use automatic properties here, and let's make this a string, and then this is name, and then here's a property, and then this is this is an int called age, and my every time I do these streams, my watch tells me that I'm sitting too long. I need to be up and active. That's probably true. All right, and then what should we do? What should we do? We've got name, we got age. Oh, you know what we'll do? I got it. This will make it nice and easy peasy. Let's call this first name, and then we'll do string last name, and then we'll do age. And just to keep it nice and super duper simple, we will go ahead and have an override for the toString, okay? And we just want to say this person's full name, and then in parentheses, we'll put their age, years old, okay? So the way that we're going to do that, there are a few ways we can make this happen, right? And you've seen one of them before. I could go through the process, and I could use a string builder. And what string builder allows me to do is I can basically gather a collection of characters and then create a giant string at the end, as opposed to having to store a bunch of string literals all at one time, and then having to go back to that at a later date, right? Or having that take up a bunch of memory, and then having to worry about memory allocation, blah, blah, blah. I can use a string builder that will help me conserve on memory. And that's a good thing. We want that. However, that's not even the coolest thing you can do, right? Because what's going to happen is if I use a string builder, then I'll have to do something to the effect, first of all, I got to make a new one, right? I got to say, okay, well, it equals a new string builder, and then maybe I prime it. Maybe I prime it with the first name value, right? And I guess technically here I could say dot append, right? I could do an append. Let's see, what's it barking about? Hang on a second. I think it doesn't know what type string builder is. Let's do that. There we go. Now it knows what a string builder is. And just to make the compiler happy, I'm going to go ahead and return sb.toString. There we go. And then here I can do dot append, and then I can do a space character, and then I could do dot append, and you can see where this is going, right? You can see that this is gonna, it gets a little verbose. It does conserve on memory, and it gives me the result that I want, but it's fairly verbose, and it's kind of obnoxious. So what's the alternative? Well, I could instead have a string, we'll just call it result, and we will say that it is, we could use concatenation, right? We could say last name plus a space, and then we could do plus first name. I'm sorry. I did this completely wrong, didn't I? Excuse me. I could do first name plus a space and then last name. Gosh, I keep doing that. Sorry. Last name and then plus a space with an open paren, and then I could do plus the age, and then plus, and then we'll do the whole year's old trick, right? We could do that, and that's perfectly fine. There's nothing wrong with that. That is one way to do it, and then of course we would just do result here. And this right here is just your tried and true concatenation, right? This is concatenation. And that's great. That's adorable. Or I could use string.format. String.format's kind of cool. String.format allows me to build a string that contains placeholders. Just little spots where you can insert data. And I can say things like, inside of a string, I would do curly braces, 0, space, curly braces, 1, space, the paren, and then curly braces 2, and then years old, right? I could do that. When I do that with the curly braces, what I'm doing is I'm marking a substitution. I'm placing a substitution marker. I'm saying at this point, I want you to take the first argument that follows this string, the first argument after this string, and I want you to insert it everywhere there is a curly brace 0. So here I would put first name. And then, comma, so this is the first argument after the string, right? Comma, last name, comma, age. By doing that, first name appears everywhere there's a curly brace 0. Last name appears everywhere there is a curly brace 1, and so on. These are just 0-based placeholders where they go through the arguments after the string. Technically, there is nothing wrong with me coming in here and throwing in some other arguments I'm allowed to do that. I can have more arguments than there are placeholders. That's perfectly fine. It's not a good idea to have fewer arguments than there are placeholders because then there's nothing to substitute. But this is called string substitution. And let me show it to you in action. If I come down here into the main method and I say person p equals new person, I am going to use a technique here. Notice that there is no special constructor that takes in all 3 of these points of data. I could technically go through and say p dot first name equals something, you know, Jake, and then p dot last name, and then we could say Dub Horst. He knows who he is. And then we could do p.age, and I honestly do not know his age, but I could say p.age equals, I'm certain he's a little older than I am, so I'm gonna go with this one. Just I'm gonna make his age the answer to life, the universe, and everything. Okay. I could do that, and then I could print it out if I wanted to. I could go ahead and print him out, right? If I go ahead and I run this thing, notice there's our toString, and that's our toString using substitution. Also, when I go to create this person, if I don't want to go through the process of calling each individual property, but I know those properties exist, after the parentheses of a constructor, I can use curly braces, and I can start talking to the properties here, and I can set them accordingly. I can drag this up, and then do a and then I can do a comma, and then I can do a last name equals, and then I can drag this up. You know what I mean. And then I can do a comma, and then we can just do age equals 42, get my closing curly brace, get my semicolon, and then these 3 lines of code are actually done here in line. It's the exact same thing. What really happens is that the object gets built, and then these fields get set. It's not like passing these arguments to a constructor where it happens at construction. The constructor happens first. Then when the constructor is done, it calls these properties for you. This is initialization syntax of an instance. Super useful. Love this feature in the language. All right, cool. So now I've got my person object initialized to these values, and you saw that I can print this out with string substitution, no problem. But that's not even my favorite way to do it. I mean, I love string substitution. String substitution is super useful. It is super useful because some of the things I can do there are, I can say that a particular value takes up a certain amount of space. Like no matter how many characters there are, it's going to take up exactly 28 characters, or if there's more than 28, it'll overflow. If I'm using digits, and I'm using like a decimal value, I can say, hey, truncate this to 2 decimal places, like when I'm using money, for example. Or I can even say, treat it like currency. Or I can say, slam the text to the right of the spacing, or slam it to the left, like left, right justified, left justified. I can do a lot of things with this, with string substitution, by modifying those placeholders. And I'm not going to go deep into that, but I want you to be aware that you can do that. You can say, I want to substitute here, and I want it to take up 17 character spaces. Or I'm going to substitute here, and I want you to treat it like currency based on the localization of the system, and so on. So string formatting is super cool because it allows me to do so many things with that substitution. But then they released C#7, and I gotta be honest with you, it got sexier. It got way sexier. It's such a small, simple thing that they did, and I love it. I love it way too much. And you're about to love it too. So, they now have something called string interpolation. By the way, over here, I'm gonna go ahead and keep this as a comment, but this is called string substitution. I forgot to write that down earlier. This one is going to be string interpolation. So here is string interpolation. And string interpolation says, hey, look, if you give me a $sign before the string, now all you have to do is refer to your fields or anything that's in scope, or an evaluation within curly braces inside the string, and I'll use it as is. So I can do first name, space, curly braces, last name, space, curly, paren, curly brace, age, and then years old. Look how concise that is. And I can use this the way that I do string substitution. In fact, technically behind the scenes, what happens is they call string format for you. In fact, if I'm not mistaken, I think they actually make a string builder and then modify some, they do a lot of stuff behind the scenes. But this effectively does a string format for you, just more concisely. And I can still say that this first field takes up 17 slots, or this number needs to be treated like currency, or this decimal value needs to be truncated to 5 significant places, and so on. I can right justify, I can left justify. I can do everything I can with string formatting, but now I don't have to say string.format and then put those placeholders and then add additional arguments. I can instead just do everything in line at the moment that I need it. And this works for anything that's in scope. I can put ternaries here because those are in-scope evaluations, right? I can call other methods that will return a result because that would be an in-scope evaluation, and so on. String interpolation is the new hotness, and it is fantastic. I love using string interpolation. So get used to doing this. It is super hot. And just to show you that it works, if I go ahead and execute this thing, sure enough, I get the exact same result as I did earlier with my string substitution, only now I'm using string interpolation. Okay. One thing I do want to make you aware of is imagine for a moment that you wanted to output something literally, that you didn't want it to be treated special. You didn't want characters to be escape characters or anything like that. I can do that by making a pre-formatted string. A pre-formatted string starts with an @ symbol, and then has the quotes, right? And I can say, like, if you want a new line, simply add, see if I can make this work, simply add /n let's do /n to your string. Now, normally that \n would cause a new line to occur in the string. For example, if I get rid of that @ symbol, right? You're not going to see any difference here, but if I hit play, then it bumps the thing down. If I put the @ symbol there, then you can see that the new line character is a literal new line. It's literally a / and an n. Because what I said with that @ was this string needs to be printed exactly as it appears. Please do not escape anything. Please do not substitute anything. Please do not. Fun fact, if I do like, let's see, let's have a string demo, and I'll just set that equal to demo string, just like that, okay? And then inside here at the very beginning, I were to do curly brace 0 curly brace. And at the end, I were to pass in demo. Notice that right now I'm in a console.write line, but I'm trying to do something like I would in substitution, right? I'm trying to do something that is substitutive? I want to substitute. When I run this, notice that the substitution takes place. That's because console.writeLine calls a string.format behind the scenes. So it's kind of nice. It has string.format built in, so you can do substitution in line, and that's really cool. But what if I want to just go ahead and pre-format that string instead? If I pre-format that string and hit play, the substitution still takes place. Do you see that? The substitution still happens. But it didn't escape my n. It didn't escape that character. So, okay, that's fine and dandy. What happens if I remove this other argument? What if I have a substitution placeholder and nothing to substitute? And I hit play. Well, at that point, it's like, oh, there's nothing to substitute. I'll just treat this normal. Would that happen if this wasn't a pre-formatted string? Let's find out. Yeah, that would still happen if it wasn't a pre-formatted string. But notice that the new line character gets escaped and becomes a special character again, right? All right. So really, the whole purpose of pre-formatting is, hey, if it's going to be a special character, don't. I want this to be literal. I want this to not be escaped. Don't escape stuff. That's effectively what the pre-formatting does. It also, if you're in a situation where normally white space would be ignored or reduced or anything like that, pre-formatting would maintain that white space. But we can play with that another day, another time. I just wanted to show you pre-formatted strings. Okay, so this is our person class, but this is technically really our string creation demo, right? Which has my favorite new hotness, string interpolation. All right, let's go ahead and collapse that down. Okay, so now that we've done that, we're gonna get into some heavy stuff now. We're gonna get into some heavy, really fantastic things. So, once upon a time, story time. Once upon a time, the folks over at Microsoft, when they were working on .NET and they wanted to improve the C# language and all that jazz, they decided they had figured out that one of the common things that needed to happen was that given any collection of anything, you might want to filter that data in some useful way. You might want to analyze that data to get some sort of useful result or some sort of interpreted outcome, right? Some sort of derived outcome. And normally that's not a problem if you think like a database developer, right? If you have a database, you can query that database and you can filter that information, and then you can aggregate that information, and you can create new information from the other information, and so on. And they were like, well, in C#, we can do that if we write all the code all the time, and we can do that to a certain degree, but wouldn't it be great if we could do that a little faster? Wouldn't it be great if we could take some collection and treat it almost like data in a database? Because really, what is a database? It's just a collection of data. Did you hear what I just said? I just said a collection of data. right? Data that relates to other pieces of data. But we have that in C# as well, right? When we have an array of something, when we have a list of something, we have a collection of that data. So they were like, well, what could we do about that? How could we then take our collections and treat them as though they were databases of information? And they came up with something called, they came up with this notion of something called language integrated query. Language integrated query means exactly what you think. It means we can actually query data that's in the language right there. We don't have to build a separate database. We don't have to build a separate representation and query that thing. We can query the collection that's in C#. That's why we have data, right, in our code, so we can do things that are useful with that data. So they came up with something called language integrated query, but to make that happen, to make that actually work, they had to come up with something that didn't quite exist yet. You see, if I have like an array or a list, let's look at a list. Let's look at a list for an example, a list of int called nums, right? I'm just going to declare that. I'm not even going to initialize it or anything. I'm going to go ahead and make sure control dot to get my usings. That's like the control shift O in Eclipse, except it's not as automatic. If I do control dot to get a suggested using to add, and then I do F12. F12 takes us to the definition of that thing. I get the metadata, and there's a ton of stuff here, but what's important is to notice that this list implements a bunch of interfaces. How do I know they're interfaces? Well, in C#, all interfaces start with an unnecessary capital I at the beginning, and that way at a glance you know this is an interface. And this is a generic version of list. That means I can put any type I want here. That's what the generic part means. In fact, it even says generic. And this is the IEnumerable generic interface. This interface, if I go there, it inherits from the regular IEnumerable, the one that is not generified, which gets an enumerator. But this IEnumerable that is generified has a get enumerator that is generic. And then it returns an object that implements the IEnumerator interface. Here's the short story of what we're looking at. The short story is that means that if I ever want to do, say, a for each over that list, where I have int num in nums, and then I want to do something with that information. I want to say something like I just want to print the number out, for example, just something to that effect. And I'll even come over here and I'll new this up so that it's, you know, the compiler's happy and all that stuff. Okay, good. So if I want to do that, what makes the for each possible is that the language can get an enumerator. An enumerator knows how to start at the beginning of that collection and then traverse the collection one item at a time. Because going item by item through an array is very similar to how you go item by item through a list. It's similar, but there's another level of abstraction there because a list is not an array, even though it manages an array. To go through every item in a queue is a little different. To go through every item in a stack is a little different. To go through every item in a linked list is very different. And through a heap and through a tree, like a B+ tree or a black-white tree or a 2-3 tree, any kind of tree is going to be different when you're traversing each of those levels. In other words, the enumerator is built for that kind of collection, and it knows how to go through. And what the enumerator does is it keeps a placeholder of where it is in the collection, and it has the ability to peek forward one space, and it has the ability to report back and say, yes, I have another item in my collection. When it gets to the end of the collection, that ability to say I have another item actually comes back false. It says, no, I don't have another item. Or it might even go to that space and say, sorry, the collection's over. And through that object, this for each does its job. The whole purpose of a for each is to go through a collection one item at a time, starting at the beginning and just going bang, 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 bang through each item, right? The only way this for each works is that an enumerator exists for that collection. So every collection in C# at some point inherits from another object or directly implements this interface, right? It inherits from an object that implements the interface, or it implements the interface itself. So in other words, at the base of every collection, in C# is this IEnumerable interface. And if it's a generic type, it'll have this IEnumerable T interface. Now that's important to know because in C#, polymorphism is a beautiful thing. It allows you to pass in any concrete type of that interface. In other words, since every collection uses that interface, any collection can be used in place of that interface if I had, say, a variable. If I had something like IEnumerable of type int nums equals a new list of ints, this is okay. I can totally do that. The only problem that my code has right now is that I have another object with the same name, right? This is perfectly fine. This is polymorphism. This says, hey, look, this variable can reference any object that is considered an IEnumerable of type int. So I could put a list here, or I could do an int array, or I could do a stack of ints, or I could do a queue of ints, or I could do a DB set of ints, and so on and so forth. I could do any kind of collection I want because I'm using this IEnumerable interface. Now, what happened was that they said, okay, if we want to be able to query every collection, let's go to the basemost thing that every collection has. And every collection has this notion of an interface called IEnumerable. And they're like, okay, cool. Well, if we had to add new features, if we had to adjust IEnumerable so that every collection had these new features, what would that take? And what they came up with, if I've got this number right, is 176 new methods, I think is the number, plus or minus 2. I'll say 174 plus or minus 2. 174 methods plus or minus 2 that they wanted to add to the IEnumerable interface. But there's a problem. If you understand how interfaces work, what happens when you change an interface? If you change an interface, it means that every class that uses that interface must now also change. And until it changes, you can't compile. So if you take something that's at the base of every collection in the C# language and has been at the base of every collection in the C# language since C# 1, and you change that, what happens to all existing code? Technically, all existing code crumbles and breaks, and now nothing works, right? Airplanes fall out of the sky, stuff like that. We don't want to do that. So Microsoft had a real problem on their hands. They're like, hey, look, we want to add these new features, but how can we do it without changing the base type, the base interface that these classes implement? And what they came up with was this wonderful and amazing new feature called extension methods. What they wanted to do was they wanted to add features that were static features, features that could exist at the class level or could statically operate on the object without having to be part of the object's definition specifically. And so they came up with something called extension methods. And they did that in a class called enumerable. Enumerable is a beautiful thing. I'm going to do control and we'll add system link. There we go. Enumerable is a beautiful thing. If we go to the enumerable definition by pressing F12, you'll see that it is a public static class. Remember static from our basics lesson? This means that this class can only have static members. It cannot be made into a new instance. It can only be static, right? It can only be a class level thing. And so here we are. We've got public static, aggregate, all, any, average. What are all these things? Man, this thing is insane, right? Here are our 176 methods. These methods, the parts in white are the names of the methods, right? The part just before it, whether it's in green or blue, that's the return type. And then you have your parameter list. And if you look carefully, you'll notice that every method is static. Every method is public and static. And every method, in this case, is generified. Well, almost every method is generified. But the most important part is that every method has a parameter that starts with this keyword. Now that's fascinating because we've only seen this inside of an instance-based method, right? But this is a static method. So what does the this mean? Well, when we're talking about extension methods, what we're saying is that the first parameter defines the target of the method. And once we know what the target of the method is, we can call that method using an object of that target type as if this method were a member of that type. Let me show you what that looks like. Let's come back over here to program. I am going to I'm gonna make a region right now. Region extension method demo. And I'm going to have a public static class called crebstensions with curly braces. And then we'll do an end region. And then we will collapse this, expand that. Okay, good. Now here, I can do a public static method. Let's see, what do we want to actually do? Well, what would be a good one? Oh, you know, let's do something really, really super simple. We often want to know if a number is even or odd, right? So let's have a bool here, and then we will call this is even. And we will take in an int, but we have to do this int called num. And once we've done that, we can return num mod 2 equals 0. This will tell us if the number is even or odd, right? If this is called is even. If it returns true, the number is even. If it returns false, the number is odd. Okay, great. So what did we actually accomplish by doing that? Well, if I come down here, I'm gonna get rid of that for a second. No, I'm gonna need that in just a little bit. So I'm gonna go ahead and just, there we go. Let me declare an int num10, right? And then let's do cw tab, and then we'll do num dot is even. In fact, I will use some string interpolation here, and I'll be like, num, and then in parentheses, I will actually put the value of num. Oh, you know what? Hang on a second. The number, and then let's do num. And then here we can get a little smart. But I'll keep it really simple. We'll do is even, and then I will just use an interpolation, put that there. Okay. So, oh, sorry, my syntax is off. There we go. So, what's going on here? Cannot convert method group. It's a method. There we go. It's a method. All right. So now notice what I'm doing there. I'm taking my int variable num, and I'm calling a method on it as if the method belongs to the int. Normally we can't do that, right? That method, that's not defined in the int class. That's not part of int 32. That's not part of the C# language natively. I made that. I added that feature, right? So let's go ahead and let's run this thing so we can see it in action. It says the number 10 is even. True. Sweet. And then if I change this to 13, I can run it, and it says that the number is false. Heck, check this out. Even if I didn't want to do that, if I came in here, I just put the number 13 literally, right? In fact, let's just do that. And then here I say 13 dot is even. Notice I'm using an int literal now, right? I'm not using the variable. I'll even comment that out so it doesn't play a role. I'm not using the variable at all. I can take the literal 13 dot is even, and then when I execute this thing, it goes, oh yeah, no, that's not even at all. That's false. If I change that number then to 14, which we know is even, I can hit play, and I didn't change the string so it said 14, but you see that the result of that check is that it returns true. So now I've got the number 14 is even, and it's true, right? This extension method, it might seem super simple, and this is a super simple extension method. That was the whole point of it, right? But what this allowed me to do was it allowed me to add functionality to a type without changing the definition of the type itself. In other words, I don't have access to change the definition of what an int is, but I just added a feature to the int. Isn't that kind of crazy? In C#, you have inheritance. Inheritance says that you can have one class, like a person class, and then if you want, you can inherit from that class in a more specific version of what that class is. For example, I could have a person class, then I could have an employee class, right? And an employee is still a person, contrary to popular belief. An employee is still a person. And that employee is going to have some of the same features as a person, so it's going to inherit those things by having a parent-child relationship. But in C#, there are cases where you don't want people to inherit from your class. If they're going to use your class, they've got to use it as is. They can't inherit from it, so they can't override stuff. They can't add new features. It's just that class. We got to keep it on lockdown, right? That's called a sealed class, and a sealed class does not allow you to inherit or extend in any way, except with extension methods. And here's why that works. You might notice that this class is static and this method is static. This is not the int class, right? This is not the int class. This is just a class that is a static class that happens to have a method that targets an int, right? So I didn't actually change the definition of int. What I did was I added a convenience helper method that acts on an int. And I can call it as though it belonged to the int, but it's not really part of the int. Here's what's really happening. And I'm going to break this out into just a little bit here. Let's go back to having a num. There we go. Okay. Let's go back to having a num, except now I'm going to add a bool called isEven. And we will set that to num.isEven the method, right? And then down here, instead of calling the method, I'm just going to use the Boolean so that you can see that it works the way it should and all that jazz. Whoopsies. Sorry. Save. All right. So if I run this now, it should still print out correctly. 13 is even false. Okay, great. Here's what's really happening. When the compiler comes through and sees this, it goes, oh, okay, you've got this variable of type int. Not a problem. Not a problem. I know what an int is. And you want this method. You want this. Oh, that's interesting. What it does is it goes to the int32 definition. And it says, excuse me, int32, do you have a method called isEven? And int32 goes, nope. And it goes, oh, well, who's your parent class? And it goes through the hierarchy. And if it can't find the definition of this method in the hierarchy of inheritance, it instead does magic, right? And it goes, oh, is there an extension method? Is there an extension method that targets an int that's called isEven? And it looks in scope and it says, oh, yeah, there is. And it's like, look, the compiler says, look, I don't know how to call a method, an instance method no less, on a type that doesn't have that definition. But what I can do is I do know how to call a static class. And I know how to call a static method within that class. I know how to do that. And what the this keyword does, the reason that this is so important is that the thing that we're targeting, when we say num.isEven, that num gets passed in as the first parameter. This right here is what's really happening. What you saw before, when we said, I'm just going to copy pasta this. I'm going to comment this out. Beforehand, we said, we said num.isEven with parentheses. This is what we call syntactic sugar. C# is full of syntactic sugar. In fact, some people are actually not as big a fan of C# because of its sugar. Some fans and opponents are made based on this sugar, right? The idea is that C# is designed for developers. And because of that, they've put a lot of shortcuts in there for developers. And one of the things they've done is they've said, hey, look, I can sugarize. I can make this a sweet, short version of what we would normally type. And then behind the scenes, the compiler will go through and metabolize that syntactic sugar and turn it into actual code, right? It will turn into actual code. You and I see the magic, but C# sees the real deal. And so the compiler goes through, sees this syntactic sugar, desugarizes it so that it is actually code that could really work. Calling a static class that has a static method, passing in the first value it requires. But thanks to the power of extension methods, I can use the this keyword, and that allows me to call the method on the object itself as if it belonged to the object. In truth, behind the scenes, it's just a static method in a static class operating on some value or some object. That's all it's doing. It's just a static method. So here's the big difference. In an extension method, if I had an object that had a private field, let's say I had a person class, which I did earlier, right? Let's say I had a person class and I had a private string social security number, and I'll just do get set. There we go. I had a private social security number, right? Or maybe this is, well, yeah, we'll keep it private. Or maybe it's just a private field. Let's just do that. I have a private string called SSN, whatever. The point is, because this is private, can an extension method access this thing? And the answer is no, it can't. Because an extension method is still an external thing. It's external to the class. It's actually defined in a different class entirely, right? Like down here, this is not the int class, this is the crextensions class. So when I go to operate on an int, can I operate on anything that's private to the int? No, I can't. That's a limitation of extensions. But that doesn't stop me from adding functionality that can access things that are visible in that object. I can statically operate on those things. That's what an extension method does. It statically operates on public or at least visible things. All right. I love extension methods. I didn't appreciate them at first, but then I understood them better. And I love extension methods. I love that they allow me to add some types of functionality to objects I otherwise could not modify, right? All right, so the reason I told you about extension methods is that LINQ, Language Integrated Query, is based entirely on extension methods. They didn't want to change the interface because if they change the interface, they break the world. So instead, they made that enumerable class that I showed you, and it has all of the extension methods. Now, what can we do with that knowledge? Now that we know about that, what can we do? Well, let's say for a moment that I have a new list, and that list has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and of course, 1337, and 0, and negative 100, okay? Let's say that my list has all those values. Not a problem, not a problem. What if I want, let's see, now that I have that list, let's come down here. No, I don't need to do that. I'll just demonstrate everything right here in this. Oh, I can see the problem. Never mind. Let me do a public static void demo link method. And I will grab this list. I will bring it down inside here. And I will just call demo link from the main. That way all my demo code is packaged up and I can move it later. All right, so what if I want to find all the even numbers, right? Like we did a moment ago. And by the way, I'm gonna come out here. Oh, you know what? This is actually a really good opportunity. Check this out. Public static void print, and I'm gonna target this enumerable t. I'll call it call for collection. And I think print also has to be generified. There we go. And then here, I'm going to say for each. What's interesting about this is I don't even know what kind of collection it is. And I don't know what T is. But I don't have to. I can just say for each T, that's its type, item, in call for collection, right? I can just do a CW. And do you want to print this vertically or on the same line? You know what? Let's print it all on the same line. I will print the item plus a tab character. Oh, tab's going to be huge. Let's just do a... I don't want to get too fancy with it. I'm not going to... I could get fancy. I don't want to get fancy. Let's just do this, okay? So I'm just going to basically print out each item next to each other on the same line. And I'm not going to get fancier or schmancier than that. But notice I made this an extension method. Why is that useful? And why did I target IEnumerable, especially this IEnumerable, right? Check this out. I can call nums dot, sorry, nums, oh, it does say nums2, doesn't it? I meant to just make that nums. So I'm going to change that. There we go. Nums dot where. And now we're going to use something called a lambda expression. A lambda expression is a super duper shorthand for I don't want to say a one-time, yeah, one time, not one call, but a one-time use method. We call this an anonymous method. It's a method that we don't know the name of, but the compiler does. And here's what it looks like. We say N or X or Bob or Susie, whatever name we want. N goes into n mod 2 equals 0. By doing this, by calling a where with this lambda expression, what I'm saying is, hey, I want you to filter on this collection for all the numbers that when they mod by 2 result in 0, right? In fact, there's a different way to write this. I could say from n in nums, where n mod 2 equals 0, select n. And then right here, I'm going to do var even nums equals this thing. Okay, Control KD. There we go. What did I just do? This right here is what we call comprehension syntax in LINQ. It is written very similarly to some other technology that Microsoft makes. What technology does it look like to you? Do you know what this looks like? Have you seen this before? What does this look like? Well, even though it's in a slightly different order, this kind of looks like SQL, right? This looks like SQL database code, which is really kind of cool. This is really awesome because that means that people who understand databases, when they get into coding, they can also understand how to filter collections, or they can think about the collection like a database. But it's a little bit different, and it's definitely in a different sequence. Usually in a SQL or MySQL, you'll find select, and then you can choose the fields you want, or splat if you want to get the whole thing, from, and then at least one table, and then where is a filtering process. So this is very, very similar to that. But it's in a different order. And I actually like this order better because the truth is that is the order in which it executes in SQL. SQL does not start with select, even though the statements do. SQL actually starts with the table or the source. And then it starts filtering. And then once it has that filtered, it starts doing the selection. And then there's some other members of the query you can do, like an order by, or you can do an in statement, or there are tons of things you can do. But this is the most common basic kind of filter that you're going to apply. And it's going to return, what this returns is technically an IEnumerable of type int, and more accurately, Control KD, more accurately, what it does is it returns a handle. It returns a handle to a result set that happens to be an IEnumerable of type int. Now, because it's an IEnumerable, I can come down here and I can say even nums dot print my extension method, right? I can do that. When I execute this, you'll see that only the even numbers appear. Oh, I should probably come up here, and at the end I'll just do a CW emptiness. There we go. Now when I run this, it'll bump the thing down to the next line. There we go. 2, 4, 6, 8, 10, 0, negative 100. It's not in any particular order though, is it? No, it's not. It's not. So maybe we want to order this, right? Maybe we want to kind of sort this. I don't know if I can make this order. I don't think I can. I'm going to show you a different way to do this, and it will make more sense. So this right here, this is comprehension syntax, right? You may have seen earlier that I used the keyword var. All var does is say, hey, look, right now, I don't know what the type is, but based on what we assign here, set the type. It's actually a compile time type. And the compiler knows what it is. If I hover over this thing, it's like, oh, notice it says it's an IEnumerable of type int. That's what it will be forevermore. It's not like var in JavaScript where it could become some other type later on. It's just right now, I don't know what it's called. So I'm going to say var, and compiler, you put the type there for me. Still strongly typed, can't be changed, but it allows us to not know. And there are cases where you and I can't possibly know what type it's going to be. But C# is a strongly typed language, and it has to have a type. So we'll see an example of that later in life, I think. So this right here, this is not how I wrote it the first time, right? This is not how I wrote it the first time. The way I wrote it the first time was down here, I said var even nums, I'll say 2 just to separate it, equals, and we did nums dot where, and then we did n goes into n mod 2 equals 0, and then technically this is also present. In other words, I want to select everything from each of these items. I take the item, give me back the whole item, that sort of thing. And then I can say even nums2 dot print, and you'll see that we get the same result twice. What you're seeing here is syntactic sugar. This is extension syntax. This is extension syntax. And what's really happening when we have a lambda expression like this is, what really happens, I'm going to go ahead and just pull that out. What really happens is that the compiler sees that and it goes, oh, you need to have a static method. And I'll be honest with you, I don't know if it's public or private or internal. I don't know. I don't know. So I'm just going to put public here anyway. Public, it's a public static method that in this case, because of the way that where is defined, it needs something called a func. A func is a special kind of what's called a delegate. And that delegate takes in an int and returns a bool. That's how functions are designed. When they're generified, all the types at the front are what they take in terms of a parameter, and the very last type is what it returns. This is called a predicate, and the reason it's called a predicate is because it is a method that returns true or false. That's what a predicate is. It returns true or false. Okay? So we know, based on that method and the fact that it's taken in a func, short for function, it's taking in a method that can subscribe to that delegate. That method needs to return a bool. It has to. And it has to have a name, but you and I don't know what that name is. This is an anonymous method, so the compiler is going to step in and give it a name. And I don't know what that name is, but just for our sake, let's call it predicate 1. And predicate 1, based on that func, has to take in an int, right? So it's taking in an int. And what's the name of that int? Well, the compiler looks at how we defined it. This right here is what we're passing in. It knows it's an int because we're operating on a collection of ints, and it knows that we want to call it n. So it goes, oh, you called it n, I'll call it n. So that arrow means pass my int into an argument called n that goes into a method with this return. In this case, it's this return. So they're like, oh, so what you're saying is return, grab this, stick it up there, and that's what our little arrow function becomes. All right, by the way, that's called a lambda expression. Some people call it an arrow function, especially if they have a JavaScript background. That's a lambda function, okay? So it takes that lambda function and converts it into this method. And then it just says, okay, cool. We're going to pass that method in. We're going to pass the method in, not the method result. We're going to pass the method itself right in to this func. You don't know how delegates work yet, and I don't know if we'll have time to get into it today. I was going to show you delegates and events, but I don't know if we're going to have enough time. But basically what's happening is that there is a special kind of object called a delegate. And that special object, that delegate, its job is to hold references to other methods so that when the time comes, it can call those methods and get their results accordingly. In this case, this function delegate, wants to take in exactly one method and call it over and over and over again to get either a true or a false result. When it gets true, it takes the item it passed in and sets that aside as part of the collection result. In other words, we're passing in a collection of ints, right? That func is going to go through, is going to be given each one of those numbers, each one of those ints, one at a time. And then that func is going to pass it to our predicate, our isEven checker, right? It's going to pass it into our delegate or to our predicate. And then it's going to say, okay, true or false, true or false. If it's true, keep the number and put it into our collection result or result collection. If it's false, throw it away. It does not go into our result collection. Excuse me. What's super cool about that, and I want you to think about this for a second. What's super cool about that is that because where is built on a delegate, an object that can store a reference to any other method as long as it returns a bool and takes in the type that the collection holds, right? As long as it does that, it can subscribe to the delegate. And because of that, where can ask the delegate to call the right method every single time to get the right set. And the truth is, you and I get to define how that works. You and I get to say, we want the objects where this thing is true. Well, the where method can't know that in advance. We have to tell it. So we give it this anonymous method. We're like, hey, use this method to figure out if I want the object or not. That means that we can filter on anything as long as we tell it how. And we can do that inline. We don't have to build another class. We don't have to build another method. We're just using a lambda expression, which is an anonymous method that we can do very quickly and inline. It is super cool. It is super cool. It means where works all the time. We just have to tell it how to filter. And that's what we're doing with our little lambda expression, right? So, but that lambda expression is syntactic sugar, and the compiler turns it into this and then passes the reference to the method. It's not calling the method, it's passing a reference to the method to this delegate, to the delegate, the func of where, okay? Now, what's interesting is that we're actually calling select on the result of where, and where is an extension method, right? Where is an extension method from the enumerable class. And that means that the thing that it targets is the object we were using in the first place. So there we go. This is actually how the where method gets called when we desugarize it. But notice that select is operating on the result of this method. And this is also an extension method, which means this comes from the enumerable class. And the object it operates on, the target, is the result of our where call. And then we get to this lambda, and the lambda expression, the compiler goes, oh, what you really want is a public static method that, and here's how a select works. If you hover over select, it has another func that takes in an int, because that's the kind of collection we're operating on, and it returns an int, because that's what we're trying to select. And it goes, yeah, no problem, man. So you need to return an int, and we're going to call this select1, and you're going to take in an int, and what did you call it? You called it n, so I'll call it n. Great, and I kid you not. And I realize how this is about to look, but I kid you not. Computer science is simple, and this is what happens next. It says, oh, return n. So we're going to pass n in, and without any alteration, we're just going to kick it back. Yep, computer science is simple. Now you might be thinking to yourself, why would I ever want to do that? Why? That just seems kind of silly. Why? That seems like a waste. Why would I ever do that, right? Well, in this case, it is a little wasteful because we're passing an int in, which is a primitive value type. We just want that primitive value type back. But what if I passed in a person and all I wanted was last names? What if I wanted a collection of last names? I don't care about first names. I don't care about ages. I don't care about social security numbers. I don't care about their wage. I don't care about any of that. I just want their last name. How do I get a collection of just their last name? Do I really want a collection of person and go through each person, then grab their last name as I need each one of those things? What if I don't need all the other data? Well, I could instead use a select, and I could be passing in a person P, but what I want to have returned is just the last name. So the func would look like you're passing in a person, but you're returning just a string. Or maybe I want their first and their last name. Not as a single string, but as an object that has the properties first name, last name. Well, I don't have a class for that. And I don't need a class for that normally. I just need it for this one query. I can make an anonymous type. That's just like an anonymous method has no name, but the compiler gives it a name. An anonymous type has no type, but the compiler gives it a type. And then we get to declare what's in there, right? Oh, hey, Wushu Yasuke. It's nice to have you there, man. Good to have you. I just now noticed the message. I'm so sorry, but it's nice to have you on board, Wushu. All right. So if I want to have a collection, a subset of data, I can use an anonymous type to do that. That's where select really comes in handy. Most of the time, we just want the full object back. That's true. I can't deny that. And I only showed it to you so you would know how it works. But because it's kind of asinine to do that, and the people at C# know that, they're like, hey, look, bro, if all you're going to do is just pass the object in and then select that object. Yeah, I realize this is what the compiler wants to do. That's cool and all, but this is the desugarized version, right? I can accomplish exactly the same thing by simply saying nums dot where, and you know what's funny? Because we have that extension method, no joke, because we have that extension method, I can just, let's see, can I do that? Can I just pass in, oh, holy crap. I think I can just pass in creb extensions. Technically, I could just pass in, I've already got a method for it. I can do creb extensions dot as even, but let's go ahead and do it the lambda way. I could say n mod 2 equals 0. And because my select is just going to be a lambda expression where I pass in the whole thing and I receive the whole thing back, because of that, C# like, bro, don't worry. You don't need that. You can just do this instead. We don't have to have that. The only time I would really use the select is if I want to get a subset of the data. All right. So this is us using link, and this is really basic link. I mean, where is very, very common. But you know what? What about an ordered list, right? I'm going to go ahead and comment out this stuff because we don't need to have it on right now. What if I wanted to have even nums ascending? Okay, so from lowest to highest. Nums dot where, and then I can do an order by, and then this one is like, again, it's going to look silly, but what I'm saying is I'm going to pass in this object, and the data that I want you to use to to order these objects is the object itself. Because in this case, it's an int, it's a primitive, they compare very easily. If I had a person, maybe I want to sort them by last name. So then I would do that. I would say P goes into P.lastname. And then it would sort it by last name because strings are sortable. As long as whatever data I'm using has a comparison capability. In other words, if I can compare two of those things at once and get a relative greater than, less than, I can sort by that thing. So here I would do an order by, and then I'm going to go ahead and use my nifty little extension method, my print, and we're just going to print this thing out. And now we have -100, 0, 2, 4, 6, 8, 10. Nice and easy peasy. But wait, bro, what if I want to have odd nums and I want them to be in descending order, right? Well, okay, fine. How do we do that? Well, the where is pretty simple. It's just slightly different than what we've seen before, right? Num or n mod 2 equals 1, not 0. That's how we know it's odd. Dot order by descending, and then just pass it the number. Again, the number is the thing we want to sort by. So we're just going to pass in the number and have it use the number. And then, oh, that's not going to make a difference. I just ran it without hitting a print. And so down here, we will do odd nums dot print, bam. Oh, I forgot my semicolon. There we go. And now we have from the largest odd number down to the smallest odd number because I did descending instead of ascending, right? You can do a kiloton of really cool things with link. And like you see here where I've got where and then I've got order by, technically you can chain these things as much as you want. You can chain over and over and over and over again to get the result you're looking for. It's just that every method, like this order by, is acting on the result of where. Where is acting on the current state of nums, and so on. If I had another thing here, I don't know, if I had a select here, again, I wouldn't in this case, but this is just for the demo. The select is going to operate on the result of the order by, and the order by is going to operate on the result of the where, and the where is going to operate on the state of the collection, right? These are non-destructive methods. In other words, they don't change the state of the method. They simply make a new collection. I'm sorry, I said a state of the method. They don't change the state of the collection. They don't change anything. They just create a new collection based on the old one. In fact, one of my favorite things to do, you might have heard me say earlier that, I put var here, but really it's an I enumerable. This one's an I ordered enumerable. And maybe that's not useful because what can I do with that, right? If I come down here to odd nums descending and I want to index into it, well, I can't because an enumerable, the interface does not define what that indexer means. The type does, but an interface is an abstract type, not a concrete type. And so it only knows that it's some type that implements that interface, and so only those interface members are safe to call. If I do a dot here, we might be able to find some interface members. Let's see. If I do this, then it's like, well, let's see, that comes, create ordered enumerable. That comes from the interface, right? All of these other ones come from the object class. And so these are all inherited methods. The rest are extension methods that come just from being an enumerable in general, right? An IEnumerable. So there isn't a lot that I can do with this object. But what if I wanted to treat it like a list? What if I want it to be like a list so I can do listy things, right? One of the extension methods we have is dot to list. And now when I hover over that variable, notice what data type that variable is. That variable now, I don't know if you can read it or not, but it says it's of type list of type int. It's a list of ints. It's no longer an I-ordered enumerable of type int. Now it's actually a concrete type. What can I do with that? Well, I can do with it whatever I can do with a list, right? Here is, let's see, let's get regular methods. We have the add method, which is from list, and we have add range and as read only and binary search. Oh, binary search, that's a fun one. And then we have clear. I can empty out the list. This is now a list, not just some interface implementing type that we don't know the type of. You also may have caught it when I was typing this earlier, but maybe I don't want a list. Maybe I want an array. You can do that too. Now when I hover over odd nums descending, it's now an int array. Isn't that awesome? Isn't that hot? Right? So what we're doing here is we're saying, look, not only do you, there are some other mechanics going on here. There's something called lazy fetch versus eager fetch. When we have that IEnumerable or that I-ordered enumerable, what we really have is a handle to a set that doesn't really exist yet. There's a lot of deep, dark corners on this that we could go into. I don't want to go into that right now because it's not pertinent. But in a more advanced conversation, we could talk about what that really means, that lazy fetch, that greedy fetch, all that stuff, right? So what I'm trying to show you here, though, is that, yes, it does return an IEnumerable, but if what you want is a specific kind of IEnumerable, like a list or an array, there are methods for that. And when you do that, it becomes a concrete type. It's no longer a handle. It's actually the collection with the values inside. You have the full set. That's actually a greedy fetch approach. And so you have the list, and you can now modify the list however you want. And since it's a new list, it is a list that has these values on its own. You can change the contents of this list, and you're not going to modify the original collection in any way. The only way that that is not true is if you have reference types, like maybe this isn't an int, maybe this is a list of person, and then you go through your results set and you start modifying the people. Well, technically, you don't have clones of the people. You just have two different collections pointing to the same instances of people. And so if one collection changes that instance, the other collection will see it as well, right? Because they're just pointing to the same objects. All right. Check out Link a little bit more. You can filter and query collections to your heart's desire. You can do so much with Link. It makes using your collections so much more dynamic. And at first, it's going to feel weird. It's going to feel spongy. You're not really sure what these lambda expressions are and stuff. Watch this again. Look at how we desugarized. And here's the desugarized version of just getting even nums in general, right? So you can see how the desugarized versions of the lambda expressions appear and what that looks like when we desugarize the link statements, because this is all just syntactic sugar. This is just sugar. I remember one time, if I can tell you a quick story, I remember one time when I was in my, I have a mentor, Jamie King. Hi, Jamie. Hi. He was my .NET guru, and he helped me build an intense love for C# and .NET. And I remember being in his class when we were in .NET 2, which was learning how to do web development in ASP.NET, which has now evolved into ASP.NET MVC, which is so superior to ASP.NET on its face. But anyway, so he was showing us ASP.NET. And that's when Link came into our purview. That's when we started to learn about Link for the first time. And then we started using it a ton, or we were expected to use it a ton in advanced C#. That was the third level of C# that we don't currently teach at Newmont, but I'd love to bring back someday. we had to use this all the time. I did not understand how delegates worked. And today we haven't really covered delegates in depth. We just talked about them very briefly, and I'd like to show you delegates. We just don't have time today. Maybe in another stream sometime. But he tried to show us how delegates worked. And LINQ works on extension methods, and it works on delegates. I didn't understand either one. I just didn't get them. And so I would try to use LINQ, and it just didn't make sense to me. So if you go through this and it doesn't make sense to you, don't worry. It doesn't make sense to a lot of people the first time through. Some people, they get it right away. But I was not one of those people. And 10 years later, well, 8 years later from the time that I took that class, 8 or 9 years, now I teach this stuff professionally. You can understand it. You can learn it. It just takes a little bit of diving in, and you're going to have to let your brain accept that the simple answer is the answer. Okay? And you're going to have to understand a few of the gears and the grease, but once you do that, all this is going to make sense. So don't hate on extension methods. Don't hate on LINQ. Don't say, oh, I hate using that stuff. People say that because they don't understand how these things function. There's nothing wrong with these tools. These tools are actually fantastic. You just have to understand how they work. And so take a moment, really look at these code examples, really listen to what was being said. If you have questions, ask me questions. You can always reach out to me. If you're on the Discord server, you can always talk to me on the Discord server. Or if you have any other questions or suggestions, you can send them to professorkrebsmedia@gmail.com. Or if you're one of my students, you know how to contact me via my teacher email. That's going to be it for today. I know we're just a little bit early. We've got 9 minutes to 3 here on my clock. But that's not enough time to get into the next meaty stuff. And we've covered a ton of ground. I mean, we covered compile time and runtime constants and how they're a little bit different in this language than they are in, say, Java or C++. We talked about the null coalescer operator, and we talked about the null check operator. We talked about string formatting and how we can use pre-formatted strings, the string format method, which includes string substitution, mind you, and of course my personal favorite, string interpolation. I love string interpolation. We also talked about string builder, but we've talked about that before. And then we hit on extension methods and LINQ, where we spent a ton of time because there's a lot of meat there. There's a ton of meat there, and we've only just barely scratched the surface on these things. But hopefully you can see the value of extension methods and adding static functionality to a type that you otherwise cannot change. And you can see the value of LINQ, which allows you to query your collections as if they were a database, because let's be honest, collections in C# are just small databases, right? They're collections of data where the data is interrelated based on the object that holds them. So we have a ton of meat here that you could check out. If you would like to see another stream on C#, I'm super happy to do one. Give me some suggestions of things you'd like to discuss. I've already got a vote for talking about static constructors, which is something I haven't used a ton of, so I'd like to explore that together. I think that'd be really fun. We could talk about delegates and events. I'd like to show you how to make some basic GUI applications, because getting into GUIs is just stupid fun once you understand how delegates work. Once we do that, you're going to get deeper into C# and you're going to have a great time with it. So hopefully you've enjoyed these streams, the 2 that we've done so far, this Christmas special, haha. And hopefully you also are more interested in C# just for yourself. You don't have to do this for school. You don't have to do it for work. You just want to know more about the language and you want to play around with it. If you have any questions, once again, you can ask me on the Discord server, or you can email me at professorkrebsmedia.com.